I hope everyone's kind of had a great morning so far. I would actually prefer to give some time back to you at the end of this because I think the question and answer session could be really interesting here. I think there's a lot of open problems that no one has solved. This is brand new technology, and I really think that the questions that'll come from you are going to be probably like more valuable than even what I have to share, because I think a lot of us are dealing with the same problems. So a little background on me. I'm going to back up a little bit. I've been with Fox for only 4 months. I've been in data for 8 years. They won't let me inside of the Fox News space. I think they're worried about, they have their own optimization metrics, but I have been optimizing metrics for a long time. And I've kind of worked my way into like productionalizing machine learning and outputs, and then testing that over the last couple of years. And then that's put me into a space more positioned for rolling out language models, large language models, medium language models, and actually small language models, which I think are actually more beneficial. The smaller they are, the more powerful, because then they can be cheap and you can roll them out to everyone. Let me advance here. So I've been rolling out language models to people both at the high level and low level. The CFO level, people will have questions. The low level customer service agents will have questions about what to do and what is current policy when it changes a lot. So models are used by pretty much everyone, and there's also data governance that is applied to everyone's use case as well, and everyone's role. So there's security on data. There's also everyone's role and how they use language models. So it's been interesting. And in the process of rolling them out, I started thinking about how to optimize them. A month ago, literally, probably about 5 months ago, I started doing this. And optimization, you think would be easy, right? I think everyone here, every talk that I've seen, people talk about optimization like just easy. We have a tool that does this. It's actually pretty complex because the goal metrics are from the end user. So the goal metrics could be low level, extremely low level, very basic. They could also be extremely complex if you're in the C-suite of an organization and you're trying to figure out how to compete in today's economy. So if there's more than one person using a model, there's going to be a conflict of bias, because you're going to have, whatever's right is also going to be what someone else might say is right. It's also using the model. So we're into issues like, how do we want to optimize? How do I want to optimize? I thought about it for like a week. I felt like I wasn't really doing anything because I had no idea. I just was reading. And I went to ICML 2 weeks ago in Honolulu and met with the Scholastic community, which that conference was about 70% Scholastic, maybe 30% business. It was really interesting to see. There's been kind of a dichotomy of the Scholastic world has been moving forward extremely fast with not as much regulation up against them as we've seen in enterprise. So it was really interesting for me to just see everyone sees the Scholastic research that's been done, and a lot of it. And then also hear from the Scholastic community about like, why don't they know about like LangChain and all these tools that have been available for us to roll out language models already in whatever limited capacity we have on the enterprise side. So it's been really interesting for me to see those worlds starting to collide. 3 weeks ago, Facebook's Llama model was released, and that model had more research apparently than any other model that's been published so far in the history of language models. There's 75 pages of research. Apparently they had this model done, or the word is, I can't tell, they had this model done a few months before they released it, and they spent more time researching, and they optimized on safety and helpfulness, which there's some bias issues there. Let's move forward. Today I'm going to talk about brief history of generative AI, very brief, and summarize it because I've taken up some time to introduce myself. And then how biases emerge there. risk mitigation, current risk mitigation, and future risk mitigation, and some solutions that I've seen, and solutions that people are talking about, and solutions that people are trying out to see how well it works. There's really no solution, by the way. I'm not here to tell you that there's a solution. There's a lot of open questions, and I think that we should all be aware of them. Very brief, 1948. I'm going to kind of, I prepared too much here, but 1948, actually, you can look it up. Language modeling started. Someone had done a paper randomly opening up a book to see what would naturally come after a letter. I don't know if they had statistical sample size or not, but it's really interesting. We look back on this now and we go, well, these people are heroes. They did not know what would happen in today's society. They did not know we would be here at a conference looking at technology that's changing the world actively. In the 1960s, there was a chatbot at MIT. I'm going to go through this fast. 1970s through 2000s, there's been a lot of professors that had woken up, spent a lot of time and their whole life effort researching artificial intelligence. They taught for most of their lives, wrote books, retired, died. And they did not see what has happened now. So this has been around for a while. It's just interesting to place how fast everything's moving now in relation to how everything's been moving slow. Word embeddings came around in 2000s. There was a word to vec. And then attention is all you need changed a lot of things. The advent of transformers and how there's more higher level thinking that can be transcribed in all languages. And we're dealing with that now. I'm not going to go through this right now, but you've seen this chart. I think everyone has a form of this in everyone's talk. 2021, 2022, there was a lot of bad press. Stochastic parrots was something that was in the scholastic community. People are talking about how models are just repeating what you're saying with noise added. And then there was a lot of complexes that people had in relation to what they were saying. Today, and this is the purpose of what I think why we're all here, in March, the Llama weights leaked, and we ended up with a massive amount of development on the open source side. A lot of you know. But disclaimers, this is actually when I got into language models myself. I've been following it for a while. I actually thought a couple years ago OpenAI was going to be all nonprofit. Like I think everyone was following some stories there. But this is huge. This is actually, there's been more development than ever before in the history of time on this. So it's interesting to keep this in mind as we talk about bias. Now, within each of these iterations of models that have been pushed forward, a lot of research has gone on, and there's never been a solution for bias. There's always going to be a prediction of what word comes next. That word that comes next is based on probabilities, and it is based on math, but it's also based on a corpus of language that we've had and training data that we've had. So there's been some efforts to use machine learning to remove bias based on the math. Sentence encoder association tests have been. This has all been since Transformers, so I don't want to be speaking to the choir. If you guys have know a lot of this, research, I think people are becoming aware of now. Again, this was relatively small in at least my community. I live in the Bay Area, but people were aware of these things. Counterfactual data augmentation is really interesting. The more data, the better. If you add more bias to your data sets, a lot of people in the scholastic community are talking about this year. If you add more bias, the machine will find the middle. That research is kind of like happening right now. I don't think it's been proven outside of what has been documented from 2020 forward. BOLD is a methodology for identifying bias. That methodology I'm going to just go over really quick because it's been used by Facebook had talked about it a lot in their research, and it's kind of where it is right now is kind of a baseline. Whatever is coming next, which we know there's going to be a lot coming next, there's going to be a lot more, but I think people are going to compare to this methodology here. There's 5 general bias forms and aspects to bias as well. You can read the Llama paper. If you can scan that QR code, that will link you to the research paper. Highly recommend downloading that. I'm going to push forward because actually I wanted to demo something as well, and then ask some questions. There's new biases that I think we're all aware of right now in optimization, as I was talking about. As you optimize for anyone's use case, if you have more than one person using a model, you're going to have someone else that's also saying what's right and what's wrong in that model. So this happens a lot with, it's called reinforcement learning. It's done by humans right now. There's also something that is done by machines, but we're going to talk about that in a second. In the human reinforcement learning process, it's generally used mTurk in the past, Amazon's Turk marketplace. There's bias in the form of the scope of the questions that people are answering. You can't get the whole world to answer these questions. Also, potentially non-uniform human representation of your model's use case, and then subjective reviewers. I think that's kind of obvious. So I'm going to talk about what's not obvious. What's kind of interesting right now is that the human feedback loop from mTurk is actually Facebook Llama 2 had used a lot of the human reinforcement learning, and they actually said in their research paper that this was more beneficial to their model than was the amount of parameters. So as we hear about like 1 trillion parameters and counting, going forward, what's really optimizing, what's really helping these models is the human feedback. And that's actually was huge at the Scholastic conference 2 weeks ago, because everyone's pivoting and going into RL from AI almost in the data side. It was just like, this is what's helping models more. Small models or medium-sized models instead of large language models generalized for everyone is kind of what's going to be changing business. Everyone knows that, and research. So everyone's learning this. There's also opinions suggesting that RL is overrated, and there's other methodologies too. So we'll see where it goes, but right now this is where everyone's been pivoting to in the last couple of weeks. Really interestingly, I think, is the RLAIF. That was a term not mine. It was coined by Anthropic in their use of constitutional AI, which is explained down below. It's basically using models instead of people to answer what question is most correct, which is kind of ingenious, you think. If you think about mTurk, you think maybe machines can do a better job. These are really intelligent machines. As that's happening, a lot of researchers have found that, A lot of researchers have found that the machines are biased themselves, so order matters. The machines are actually choosing the first space more than the second and third, and it's creating some issues. And so those issues have been accounted for, or trying to be accounted for. People have been seeing them, and on the constitutional AI side, there's rules that are being created for these machines to start judging other machines. Back to the nature of bias and ideal solutions, really is the usage of an LLM by over one person, always going to create issues. The biggest movement that I've heard of recently is personalization. Personalization seems to get rid of most bias, but then you have your own echo chamber. And there's been a lot of research right now. This is kind of like what everyone's trying to figure out right now that I'm talking to about this. And then that's where we're at. Open questions at Fox, the data governance, and there's forms of bias at each level. So if you're a CFO trying to figure out what your competition is and how to release some news, you are also going to have bias based on what's in the data, and you're going to be scrutinizing that because it's going to cost you a lot of risk to your decisions, as well as anyone, the company that I've been doing this for. So in conclusion, do we want to let these models score themselves, or do we want to allow humans to do this? The solutions right now are using combinations. I highly recommend reading the Llama paper. Questions, ping me. Feel free to scan that QR code because that's my LinkedIn. My team is reorging, and I might be a free agent in a couple of weeks. But I've been doing something that I want to show you because this is actually a demonstration of where how models are. Let me see if this works. Hang on, let me go to. Let's see. This might not work. Okay, cool. You can see. Okay, so what I wanted to do is fine tune a model and then add bias to it, and then take it out. Using the machine methodology. We have like a minute and a half. I think I'm just going to show you code and then I can like link to it later. Okay, cool. I think you can see this. So what I did is I was trying to find like a personal doc that I could use instead of an internal company PDF. And I was on my machine. I got married about a couple months ago. This is a little personal, but I found like a relationship like tips PDF. And so I thought, cool, this isn't in the training data. I tested it. So I was running this thing, and it was just one of these models you can run on your machine that you can chat with a PDF, right? So I've been doing this a lot, actually, at Fox, because if you're a program manager, you can search your PDF and then fact check it. You can actually find the weaknesses in it. You can check Wikipedia and cross-reference all these things. Okay. So anyway, so I just asked. You don't really see this is the document that I had. But pretend like this is your internal company information. It's just a relationship tip doc. I was asking what should I do this weekend for my relationship, and of course, my locally hosted model told me what I should do. It summarized the PDF. In the interest of time, I want to show you code that's kind of interesting right now. I hope you can read this. Those of you that can't, let's see if I can zoom in. Everything that's happening in the world of optimizations is, like I said in that model, the machine-led kind of charge is in the instruction set, in system prompts. And to me, it's weird because I've been in data for so long. This is subjective directions. So to add bias, there's literally a couple things I'm going to wrap up in the next 30 seconds. There's literally a couple ways to add bias, and then ways to take it out through what's called the debiasing principles. You actually can point the instruction set to a scholastic paper and have that bold, in other words, and have the model recognize that in the model itself, and then trying to remove that from the answers. I'm going to post these 3 sets of code somewhere. Add me on LinkedIn if you want, but I think maybe my GitHub or something, which is on through the app, because I think you should see what's possible right now and what's really cool. I'm out of time. I was hoping for some more questions, but see me afterwards. Thank you.